you to put 105 volts where it says with 1 ohm in neutral, voltage branch 1, 100.5. Branch 2, my voltage across branch 2 is 105.9 volts. So 105.9, 100.5. You'll notice I'm just going to de-energize this so it's not so bright and warm in here. So now the difference of the voltage between branch 1, 100.5, branch 2, 105.9. The voltage difference now is 5.4 volts. The voltage total, branch 1, branch 2, if you add both of those together, they will give us a total of 206.4 volts. And I want you to record that. Okay. The last part here, it's asking us to put a total of 3 ohms of resistance into our neutral conductor. So I'm just going to change my connection here. I'm just going to lay this one down. And what I'm going to do is I've got 3 individual 1 ohm resistors, and now I'm going to put the 3 1 ohm resistors in series with each other. So I'm going to come out of the first resistor, feed into the second resistor. I'm going to come out of the second resistor, come into third resistor, and come out of third resistor and feed my neutral to both of my branches. So now what I've done is I have 3 1 ohm resistors in series, so a total of 3 ohms from my power supply to the connection of both of my branch circuits. Okay, and then we're going to record voltages, and I'm going to ask you to record these values in your chart. All right, so I'm going to energize this and record voltages here. So with 3 ohms of resistance, and looking at your chart number 1, branch number 1 for the 3 lights here, my voltage here is 97.6 volts. So that's 97.6. And my branch 2 voltage is 108.8 volts. 108.8. Just going to de-energize this. So again, 97.6 with 3 ohms in neutral, and 108.8 with 3 ohms in neutral. The difference between the two, you can calculate it. The difference between branch 1 and branch 2, now the voltage is a difference of 11.2 volts. So that's a difference, 11.2 volts. And yet our total voltage, branch 1 plus branch 2, is still 206.4 volts. Okay. The last part of our lab here is asking us to connect a switch at point A in your drawing. So if you look at your drawing in branch 1, between first light and second light, they want me to put a single pole switch, and this would be basically point A. All right, so I've got a single pole switch. All right, so what I'm going to do here, I've got my voltmeter. I'm just going to disconnect my voltmeter for a second. The connection that was connecting light 1 to light 2, I'm going to break this connection right now and put it into my single pole switch, which of course I'm going to bond out right away. here. So I bonded my switch. So this represents the connection for light 2 and light 3. Now I need to come out of light 1 into my switch. And what I'm going to do is I'm just going to use a red, actually no, I'll keep a black wire here. So I'm going to come out of the first light in my branch 1 and go into my switch. Okay. So now this is my point A in your drawing, that the connection between light 1 here and light 2 here now flows through a switch. All right. We're going to look at what happens here. So I've got my switch in place, and we're going to record the voltage with my switch open and my switch closed. Right now my switch is closed. Okay, I'm going to re-energize my Edison 3 wire. Oops, sorry. Let me just fix something here because I disconnected one of my voltmeter connections. Okay, so my voltmeter here is connected across light 1 of 3 in branch 1, because the lab is asking, install a switch at point A in the circuit and observe the voltage at lamp 1 with the switch open and the switch closed. Okay, apparently now I'm ready to go. So let's fire this up. Now, I have the switch closed, so I'm recording a voltage here. Switch closed, I have 97.3 volts. Okay, switch closed, so really I have still the original circuit, 3 1-ohm resistors in series with neutral, and still with my switch closed, 97.6 volts. Now when I break the connection at point A, now I have my switch open, I've lost my 2 lights, my second and third. Now my voltage with my switch open, I now have a voltage of 105.3 volts. Okay, 105.3 volts, which right now is the same voltage that I'm getting on branch 2. These two voltages now match each other. Okay, now I'm just going to de-energize here. So we've got a couple questions here in your lab, and the first question says, did the volt difference increase with more resistance added to the neutral? Well, look at your column in your chart 1, voltage difference. When we had no resistors in place at all, no resistances in the neutral, we had a voltage difference between branch 1, branch 2 of 2.4 volts. Okay? When we added just a single 1-ohm resistor, our voltage changed, or voltage difference changed. It jumped from 2.4 to 5.4 volts. And then when we added 3 ohms of resistance in the neutral, we jumped from 5.4 volts to 11.2 volts. So the answer would be yes, our voltage increased every time we had more resistance in the neutral. There was a difference of we jumped up to 11.2 volts with 3 ohms of resistance, where with no resistance we only had 2.4 volts. Okay, so we did increase. We did step 2, and we put the switch to make a break at point A, and there's a question 3 that asks, where would you typically see this result occur? When we open the switch to disengage these 2 lights, basically branch 1 only saw a 100 watt load, and branch 2 had a 100 watt load. Now they were actually a balanced circuit. If we were to measure current on the neutral, there would be virtually no current because now our two loads were balanced. The whole time when we had 3 lamps in branch 1, we had a 300 watt load here, branch 1, and a 100 watt load in branch 2. So we always had an unbalanced circuit. Okay, we saw that with our voltages were different, and our currents would also be different between the two. All right, make sure you have those values recorded in your chart, and you can see the difference of having no resistance in your neutral to having as much as 3 ohms of resistance. And then also what we did is we broke light 2 and light 1, those 2 loads that were part of branch number 1, and we created a balanced load where branch 1 had 100 watt load, branch 2 had a 100 watt load. Thank you very much.